Hello, today we're going to be discussing section 2.2, which is on translations. Our essential question for the day is, how can you arrange tiles to make a tessellation? A translation is simply when you take an object or a shape and slide it from one place to another. We're not turning the object, we're not flipping the object, we're simply pushing it from where it was to where we want it to be. So in example 1a, we're going to start with the red figure and go to the blue figure. So if I start with the red figure here in example A, and I want to end with my figure in the place of this blue one, all I would need to do is push it. So that would be an example of a translation. In example 1b, if I want to start with my red figure on the left here and have it end where this blue figure is, I don't simply just push the figure to the right. I would need to tip the figure over and then push it. So that is not just a translation. That would be a translation after we have rotated. So part B is no, it is not a translation of the red figure. We can also translate in a coordinate plane. We simply move each point in a figure according to the directions that they would like us to translate. For example, we can move 3 units down, 2 units up, or we can move 2 units to the left and 1 unit down. All we are going to do is pick up each point in our shape and translate it according to the direction. So for example, if I wanted to move this point B 4 units to the right, I would simply count 1, 2, 3, 4, and my new B would be located here. However, if I wanted to move it 4 units to the right and 3 units down, I would count 1, 2, 3, 4 to the right, and also 3 units down, 1, 2, 3, before placing my dot. So B would be located here at this point. Notice on that point, the point is no longer called B. Instead, we refer to it as B prime. There's a little dash at the top of the B. And what that means is that this is the new B. The old one has no dash, that's the original. The new one has a dash denoting that this is where we're ending. If we want to notate it using coordinates, we can take our coordinate and write exactly how we would like to move the figure. Since x is horizontal, if I want to move to the right, I would simply add a number to the x. If I wanted to move to the left, I would simply subtract a number from the x. So in this example, since I moved 4 units to the right, I would have x plus 4 here. I also then moved 3 units down, so my y value is going to have a number either added or subtracted to it. My b tells me exactly how much I'm moving up or down. Since in this case I'm moving down 3, I would actually have a minus 3 after the y. In example 2, we're going to take the red triangle in the graph and move it 3 units to the right and 2 units down. If I move B 3 units to the right first, I end with 1, 2, 3, a point right here. If I move A 3 units to the right, I end up with 1, 2, 3, a coordinate here. And C, if I move 3 units to the right, my coordinate is here. If I simply count those coordinates, I find that if I move to the right, A becomes the point 0, 1, B becomes the point 2, 4, and C becomes the point 1, negative 1. From there, I'm then going to also move 3 units down. So I'm going to take each of those coordinates and move them 3 units down. Remember, if you'd like, you can look at the coordinates here, these new blue dots that I have drawn, or you can simply subtract 3 from all of the y values in the coordinates. So instead of looking at the graph, this time I'll just take my y value of 1. Since I want to move 3 units down, I will subtract 3 from that y value of 1. In doing so, I find that my new a value is a coordinate of 0, negative 2. For b, I can do the same. I can either count it on the coordinate plane, taking this point B that's already been moved 3 places to the right, and then move it 3 places down, or I can take my coordinate and subtract 3 from the y value. When I subtract 3 from the y value, my x value doesn't change, because I'm not moving it right anymore, but moving it 3 units down causes this 4 to become a 1. So my new point is 2, 1. Same thing for C. You can either count it on the coordinate plane or simply subtract 3 from the y value and move it 3 units down. Since we're not moving it to the right anymore, my x value is going to stay a 1, but my new y value becomes a negative 4. So after the translation of moving it both right and then down, these are my 3 new ordered pairs. Since they are the new ordered pairs, my last step would be to write them using the correct notation. So our final coordinates are that my new A, or what we call A prime with this little dash up at the top, has the coordinate 0, 2, not 3. My new B has a coordinate of 2, 1, and my new C, or C prime, has a coordinate of 1, 4. In example 3 on our next slide, we're going to first draw our original square in the coordinate plane, and then we're going to translate it 4 units to the left and 6 units up. Go ahead to take a moment and pause the video and try this on your own before I jump in to join you. Here I have plotted my square with the coordinates a, b, c, d. If I look on my graph and simply count the translation of 4 units left, 6 units up, I would take my A, count 1, 2, 3, 4 units to the left, and then 1, 2, 3, 4, 5, 6, 6 units up, and I should have an A coordinate here. That would be my A prime. I can do that with all the other 3 vertices, and my square would now be located here in the top left quadrant, or the second quadrant of my coordinate plane. Originally, my 4 coordinates were A, B, C, D, and these are simply what they gave to me in the question. Now, if I don't want to use a coordinate plane, I can simply translate 4 units left by subtracting 4 from all of my x values. I can then go 6 units up by adding 6 to all of my y values. So here my new A prime would have the same x value, but now I'm subtracting 4 since we're moving it to the left. And I have the same y value, but we're adding 6 since we are moving it up. For B, my B prime is going to have an x value of 3, but we're subtracting 4 to move it left. My y value adds 6 to move it up. For C, I have 3 minus 4 to move it left, and negative 4 plus 6 to move it up. And lastly, for D, I subtract 4 to move it left and add 6 to move it up. So then, my final coordinates would be A prime is negative 3, 4, B prime is negative 1, 4, C prime is negative 1, negative 2, and D prime is negative 3, negative 2. And if you plot all of these 4, you should end up with the same square that I have drawn in my coordinate plane. So my final answer would be these 4 coordinates here to the right. Right, there's one more opportunity for you to try one on your own. Go ahead and pause the video and I'll join up with you in just a moment. So your 2 triangles should be as I have here on my graph. The red is your original, and that's noted by the A, B, and C with no dashes, just plain letters, while the blue is your new triangle, and we know that because we have those little prime dashes above each of the letters. So my original coordinates, A is negative 2, 2, B is 0, 2, and C is 3, 0. I'm going to move left 1 and up 2, so I'm going to subtract 1 from my x and add 2 to my y for A, B, and C, giving me my final coordinates of A prime is negative 3, 0, B prime is negative 1, 4, and C prime is 2, 2. So these 3 coordinates would be your final answer. Thanks so much for watching. I hope you all have an excellent rest of your day.